Today I am going to look into um, porting this C++ project into a format I can use, WebAssembly, inside of a web browser. I've already looked at this for I've already looked at this for a while. Well, not too long, but I've looked at this for a day or so, just trying to figure stuff out. But um, and I made some progress, but I'll pretty much be starting from scratch because it's been a little while or a few days since I looked at it. But um, first thing I wanted to look at, I did find some stuff on GitHub regarding this stuff, related projects. So this is a guy that wrote basically a post on how he went about doing the same thing but with a different solver. Let me see what he said. Um, One thing pretty nice about this is, wait, what is this guy saying? This makes things clunky if we want to say visualize solutions, solve models. Yeah, that's true. These are good points. Another huge thing, and I think it's a benefit of WebAssembly in general, is that it can significantly reduce cost. If you had a business or a web application that used a backend that ran a solver, um, I think that could cost a lot of money, and it's somewhat complicated to get it set up, um, and scale it, at least for me. But if nothing else, I think it'd be pretty expensive, and you can cut a lot of that cost by running the solver in the browser. There is a web app that I do want to make with the solver after I get this working. Um, but I'll do that in the future. But for now, I just want to get it working, just the solver by itself in the browser. That is the goal. Um, there are some downsides of having it run in the browser instead of the server. Probably two of them. If you had proprietary solver algorithm or something that you wanted to not have users download the code, then maybe you'd want to have that in the back end and do the processing there. And also, not everyone has a nice computer, or I shouldn't say nice computer. Not everyone has a computer that is powerful enough to make these solvers work, or any sort of uh, something that takes compute power work in a reasonable amount of time. And it also takes the user system resources. So there's definitely benefits to or downsides to having things run in the client. Um, but for me personally, again, as I said before, like if I created an application that was useful and I had several users or multiple users, I probably could not afford to keep it going unless I set up some sort of business model, or some sort of subscription business and to pay for the server costs. But yeah, it would be nice to not have to deal with that at first or anything like that, and just have it work, and not also not deal with the complexity of setting up a backend uh, that will handle multiple users running different solves at different times. All right, anyways, so I did read into this a little bit, what this guy did, and he ended up using, so he had ambitions of trying CBC, which is what I'm going to attempt to do. but there was way too much linking to try as a first pass. So I have very little experience with C++, C, compiling, program, linking, all that stuff. So this will be an opportunity to learn. I think this is a project, just getting this by itself working, um, assuming it's possible, and I think it is. Well, I know it's possible without modifying the code. It may or may not be possible, but I think it should be possible without modifying the code, and it will even just getting it set up without touching the code and just making it run in the browser for me, since I have limited experience, will be quite a project, I think. We'll see. Um, so yeah, this guy it uses a different solver, so I might refer to this to get some help, possibly if it's relatable to what I want to use. Um, so this solver that I want to try to port over is written in C++ and it was created by someone I believe that worked at IBM a while back. Let me see. I think it talks about it down here. Yeah. Developed by John Forrest, now retired from IBM Research. So, and as far as I know, it's kind of stood the test of time and it's still used. I'm not 100% on that. And I know there's commercial paid solvers as well, or I think there is. Anyways, let's look at a couple other. Did I look at that one? Oh yeah, this is what I was looking at. Now this one I found, CLP is, if we go back here to their main page that lists their repositories, and we go to CLP. CLP is an open source linear programming solver as well. Um, so I don't get, I guess this is a mixed integer linear programming solver. This might be too, to be honest, I don't know. Um, but the reason I really want to get this working is because the project I'm going to be working on um, uses this solver and we can easily um, make it work if I can get this working. If I got a different solver working, it would take definitely some changes to the code base of the other project, which I think at this point is probably fine because um, that project's not really maintained, and I'll get into that project later, not right now, but that project's not really, as far as I can tell, maintained anymore. So that would be one benefit of definitely making sure I use something that's compatible, because then every change that, um, every update that's made to the other project, I'd have to keep it in sync with my changes. So that could be an issue, but I don't think that'd be an issue if I had to, because again, that project is not, I haven't seen it updated in a long time. Okay, so I think what these people did is possibly, wait, is this the other one? Yeah, they possibly ported this one over. I don't know if it's this exact one or I think it is. That brings linear programming library CLP to the browser and via WebAssembly to the browser and Node.js via WebAssembly, given the limited precision. So this is something I am a little bit concerned about. Well, not concerned, but it's something I need to think about at least, because if they had to do what they're talking about here, maybe I'll have to do that to get to work properly. but we'll see. We will see. So let me see. Given the library is compiled with custom, okay, the interface supports high level LP format. It's just the numeric precision. So again, this would be probably nice to use, but I might have to make some changes to the other project. Plus, on top of that, I would just like to just try to get this working. If I don't get it working, that's fine, but it would be pretty cool to try. A pretty interesting project to see if I can get it working. You could try the solver here. So I've already went to this. Let's go again. So this is an LP problem. You have to usually want to maximize or minimize some function called the objective function subject to constraints. And these constraints are, and the objective, and all of these are linear. Why is that? Start with a plus. I guess it's like 0 plus or something like that. I don't know. So let's say, for example, 5x plus 2y or x2. I wonder if we could change this to y and it would work. Whatever. I think it's a little bit easier to see the difference. Let's try it, see if it works. Subject to constraint 1 is, let's say x plus y is less than 10, and 3x plus y is less than 20. See if this works. Objective value, solution 5 and 5. So yeah, that does work. So this is the maximum amount that you plug into x and y to have it satisfy both of these constraints. Let's see if that works. 5 plus 5 less than or equal to 10. Yes. And it could probably be different if we increase this. Let's increase this to like 30. 0 and 20. Let's go back to 10 now. So 5 plus 5 is less than, let's add a couple more constraints. Constraint 3, I don't know if I need that plus, but we'll say x is less than or equal to 5, and 5 plus 4, y is less than or equal to 4, just so it makes sure they're well, that they might be different numbers. So yeah, 5 plus 4 is less than or equal to 10, so it satisfies that constraint. We can see it definitely satisfies both of those. 3 times 5 is 15, plus 4 is less than 20. So, and we could say, I don't know, let's just do something else greater than 5. Yeah, we'll get the same answer. It's the same thing basically. Anyways, but that's how that works. So if I change this back to 5, it'll go up to 5, right? Um, why is that not actually? Oh, there it goes. Okay. It didn't satisfy the other constraint, I guess. Okay. So yeah, that's that. There is a way to, um, so say we do equal to 2, right? Vector value, hold on. So 2 plus 0 less than 1. Yeah. So you can have, wait, is this the solution? 3. Oh, hold on. We need, I don't want any zeros. Greater than 0. Greater than 0. What? It froze. Did it freeze? Yeah, I can't type anymore. I don't know, but you can't have uh you can have a problem that has an infeasible solution, basically. So it looked like the air handling with this didn't work properly. But anyways, but you can try this over here. Okay, you need Docker installed on your system. So this is what makes me, I mean, it's not a big deal. I don't have Docker installed right now. It's not a big deal to install Docker, excuse me. But why? I don't know. Like I'd rather not use Docker. So I don't even want to run this. npm install CLP wasm. For browser-based example, please look at live demo. Let's look at live demo. Let's look at the source code. So I could download this probably, save as, and use the project. But again, maybe I will if I can't get anything else working. But for now, I'm gonna try to get this ported over. We already looked at that one. Close that. Oh no, I'll leave that open for now. This one I just saw today. I haven't really looked at it, but all this is a port, or not a port, a fork of Google optimization tools. So let me bookmark that. I'm gonna bookmark all these. Let me look at this really quick. So there's a constraint programming solver, linear programming solvers, and it looks like it was written in C++, just like the other solver, but also provides wrappers for those languages. That doesn't help me right now. Um, Actually, let me see what this guy did. I don't think he says exactly what he did, but maybe there's some changes in here. I don't know. It's hard to tell without looking through it. I'm assuming this doesn't have wasm out of the box. No. Anyways, all right. So we'll read through this really quick and see what this guy came up with. Introduction to WebAssembly. These actually might be pretty useful. Let's take a look at these. Make a new project. WebAssembly is a binary instruction format. WebAssembly means high-level languages running in the browser, nicely operating with JavaScript. Okay. We'll need to compile. To start, we'll need something to compile to WASM and compile with. It's called Emscripten or Emscripten, which is something I already have pulled up. Follow the instructions. I'm working on a multimedia project for encoding audio. I was wondering how easy would it be to port a standalone encoder to the browser? Any C++ project will do it as long as it uses the standard configure, make install toolchain. And this does have that. If you look down here, we do have the old configure, make install test. I'm not sure if we need that or not, but we'll see. On the project. Once the Emscripten is set up, tired. We can run the compiler on C++ project with the following commands. Not every project has autoconf. That's age. Let's see if ours does. .sh. Nope. Here. Okay. These steps might be slightly different for a given project. Oh man. I don't think I'm gonna last too long today. We'll see. It is recommended to consult the project documentation for compilation instructions and then substitute configure with em configure and make with em make. So I did look at this earlier, and that is part of or it is in the documentation. So if you go to porting, and this is something that interests me too, where I don't think, by the way, this or that other one I had pulled up probably it's not using threads. And WebAssembly has pthreads support. Well, I shouldn't have done that. WebAssembly, you can use threads. So that could be useful. And another reason to do it from scratch or to get this working. I mean, because I know for sure this has support for threads because I've been here and where is that? Oh, here it is. Why am I missing something? I know it's in here. Oh, here it is. If you want to build a parallel version of CBC using Visual Studio. So this I might end up doing using Visual Studio, maybe. We'll see. But for now, I just want to get the non-threaded version working first, if I can. So these steps, okay. In the last command, oh, what I was gonna say about this, by the way, importing, and where was I? What? Building project? Building large projects with Emscripten is very easy, provides two simple scripts that configure your make files to use emcc as a drop-in replacement for GCC, which is a compiler. In most cases, the rest of your project's current build system remains unchanged. Let me just double check. I'm like 90% sure it's a compiler. GCC compiler. The GNU compiler collection includes front ends. Yeah. Okay. It's a compiler. Yes. All right. Um, Integrating a build system. To build using Emscripten, you need to replace GCC with CC in your make files. This is done using emconfigure, which sets the appropriate environment variables like that. And consider the case where you normally build with the following commands: configure, make. To build Emscripten, you would instead use these commands: configure, make. Okay. So actually, the first step I want to do, which I don't think it's going to work, um, I don't think it's going to work. I don't know exactly how Emscripten works, but I want to build it first with, well, based on what this is saying, it's probably not going to work because they say you need to replace GCC with the MCC. But I want to just try building it normally using these instructions over here from the CBC page and getting it to run, you know, on the computer. And then I might be able to use that build, although I don't think so. And the output of that build to then use those files to build it to wasm, but I don't think so. I think I'll have to do this first, but I'm going to try to build it and just get it running without considering WebAssembly first and then go from there. Okay, so let me keep reading. If the last command succeeds, you should have compiled LLVM bytecode. Let me read about this. I think this is a way to, it's like a middleman. Let me read this. LLVM project is a collection of modular and reusable compiler toolchain technologies. Despite its name, LLVM, the name LLVM, it's the full name of the project. Despite its name, LLVM has little to do with virtual machines. It's a research project. Dynamic compilation of arbitrary programming languages. So it's not, I don't know if it would be a middleman, but you can use it to compile multiple languages, which is nice. And yeah, I'm new to, kind of not new, brand new, but I don't know much about this stuff, so learning along the way. Sort of an intermediary format before the final wasm binary somewhere. Figuring out where it exactly is a bit tricky and depends on the project setup. Usually the last line's printed from make command. Should give you a good hint. In my case, the result is that libs AAC and you can make sure you're looking at the right format by running file on the output file. Oh, really? Okay. I actually want to try that. I did not know that. That could tell you the type of file. So let's try that. So what I'm going to do is I don't have WSL Windows. I don't have WSL set up. Not going to set it up right now. And I don't have any sort of virtual machine software. I don't have Windows Pro. So I don't have anything set up to do virtual machine with Linux. So what I'm going to do is set up a server with Linux. There's a lot of places you could do that. DigitalOcean, Linode. Are they still around? I've actually never used them. I heard of them though. Linode, still around, I think. DigitalOcean, I've used this. I still have credits on there, I think. DigitalOcean, um, Google Cloud Platform, Azure. I don't know. There's a ton of places you could quickly set up a Linux server. from my experience, light sail, and you can do it on EC2 as well, but light sail is really quick, easy, and it's also really easy to go from light sail and save files into an S3 bucket, which I might want to do. Test stuff out and just get stuff out of there without sending it up to a repository or using some sort of other method like SCP or something. Um, but let's set one of these up. Let's go with OS only. I'm gonna go with, I don't know much about Amazon Linux. Actually, I don't know much about any of these, but I know Ubuntu usually has a lot more, a ton of stuff built on top of it, and that might be the best option. I'm gonna try Debian. I think it's a little bit more minimal, and just see if it works. And go from there. Let me see if the prices change on these. I'm just wondering, based on the image. Probably not. Yeah. So these are all first 3 months free. I don't know. I'm just gonna go with, I might as well go with this one if it's free. It's fine. I don't have a reason to save this for anything else, so not a big deal. I don't know how this works. Like, if I do this one free, then do I get to do that one? Or is it only the first one you do? If it's the first one you do, I should definitely do the highest one, right? So let's just go with the $10 one. Why not? That's fine. I'll stick with the default name and create instance. Close this message. So, oh, we already have one running. I already set one of these up actually. But I'm gonna use the new one. It's fine. And what else do I want to do? Oh, one thing you could do that I was just talking about is you can go to storage and create a bucket, and then like easy way to store data from your light sail instance. Another reason I want to use AWS light sail is I mean, from my experience, their command line is I mean their web command line interface works pretty well. Okay, so I don't feel like setting up a connection through another interface. Um, what are we gonna do here? Let's keep reading this. Oh yeah, I want to try out file. I am gonna be working in just admin, or what is admin? I was thinking that was root, but no, it's something else. I'll just be working in that. I'm not gonna make another user or anything. Um, so let's do pwd. So we're in the home directory of admin. It's fine. So if I go here, it'd be in the same place, right? Yeah, okay. So I'm gonna make a directory called uh, CBC test, and then change directories. CBC test, and I'm gonna make a file, testing.txt. And then if I do file, that's what I want to do. File, single text empty. Okay, interesting. All right, let's do rm testing. So that's working. Let's keep reading this. So I want to come back to this because I had compiled it earlier actually, and I didn't try this. It wasn't working, but the last step is producing a wasm binary in a JavaScript wrapper from the LLVM binary. It usually goes like this. Okay. Where project.bc is the binary produced in the previous step. If it does not have a BC extension, just rename it. Otherwise, I'm not sure it's true. From what I read, I don't think that's true. Probably have to include shared dependencies main. This step requires familiarity with the build tools and the project or finding or some intuition. If it's not obvious, what the dependencies are trying to find in their folder. Okay. So result in JavaScript file and a wasm file ready to be executed from Node.js. So emcc that output is that. If you load the same file in a browser using a script tag or open the generated, get the same output log to the console. Cool, but not useful. Extra imported runtime methods, FS, file system API. With the recompile module at hand, we have to write a bit of glue code. Interacting with the generated code is possible via the exposed module object. Okay. I probably will want this. It seems like a pretty decent guide compared to some other ones I've seen, so let's read this one. Compiler is just part of Emscripten. What if we stripped away all the bells and whistles and use just the compiler? But it does so much more than just compiling. Okay, Emscripten emulates the entire POSIX operating system for you. Yeah, and all this is possible to do on Windows. It's just I ran into a bunch of issues. It's just easier, but it is possible, I think, to do on Windows. Just not as easy. That's why I'm using Linux. If you use OpenGL, will bundle. Okay, that requires. Okay. Ah, it has a front end compiler that compiles your code to an intermediate representation. This IR is called LLVM, as the IR is modeled around a low level virtual machine, hence the name. Did that guy say it has nothing to do with virtual machines? I mean, not the guy, the page, but I guess this isn't necessarily saying it has to do with that. I don't know. The backend compiler then takes care of translating the IR to the host machine code. The advantage of this strict separation is that adding support for new architecture merely requires adding a new backend compiler. Ooh. Well, I see what this guy is doing. He's just using LLVM or whatever, I guess. We'll be looking at some low-level file formats like raw WebAssembly here. If you're struggling with that, that's okay. You don't need to understand the entire blog post to make good use of WebAssembly. If you're here for copy pastables, look at the compiler invocation in the optimizing section. But if you're interested, keep going. I also wrote Introduction to Raw WebAssembly and WAT previously, which covers the basics needed to understand this post. Our program for this journey is going to be super simple. Okay, mind boggling. Eventually, okay. This program. Okay. The first step is to turn our C program into LLVM-IR. What was it? Intermediate representation? Yeah. This is the job of the front end compiler. Okay. As a result, we'll get add.ll containing, I'm only showing this for completeness. Okay. Probably don't need to read through all this right now, but let's keep going for now. The output add.o is effectively a valid WebAssembly module. Okay. Just module linking. Okay, linking. Traditionally, the linker's job is to assemble multiple object files into the executable, but it has to be invoked when of the target's specific symlinks. For WebAssembly, there is wasm LB. Of course, the most important part is to see if this actually works. Okay. Hmm. So we don't need Emscripten. Probably will want it though. Mostly because if this works, that'd be nice. Um, aggressive optimizations. So in, let's see the O3 before, right here. O3, which additional optimization. This is a good setting for a release build. Okay. Going into the standard library. It seems logical to add. Looking to adding, but I'm gonna be honest, it's not gonna be easy. Okay. Yeah, this is probably why I need to use Emscripten, right? I mean, I'm sure there's a lot of stuff that it will do that it would take quite a while to figure out. Probably not be worth the effort. Um, okay. Dynamic memory. Either I missed something or I don't know what WAT is. What? So, let's read this. Russ says yes, other people say no. Before we can solve that distance, when you go to the WebAssembly, the very first thing you see is it's a stack-based virtual machine. WebAssembly. WebAssembly is famous for neither web nor assembly. It does share some characteristics with other assembly languages. For example, the spec. Oh, this is huge. Wow. Okay, I'm not going to read through that right now. Contains both the specification for the, I mean, I don't know why I thought it would be small. Or I didn't think it would be small, but I don't know why I was surprised it was big. Both the specification for the binary representation as well as a human readable text representation. This text format is called WAT WebAssembly text format. Okay. Now what he's talking about makes perfect sense. So I didn't know what he was talking about before. You can use WAT to handcraft WebAssembly modules, turn a wasm module into WAT, or to turn a WAT file back into wasm, use wasm to WAT or WAT to wasm from WebAssembly binary toolkit. Small module. I'm not going to explain all the details. Okay. For what I'm doing, I don't think this will matter at all, but I'll look at it. File size for the module expression, which is a list of declarations, what the module contains. This can be a multitude of things, but in this case, it's just a declaration of a function and an export statement. Everything that starts with $sign is a named identifier. Okay. It is turned into a unique number during compilation. The identifiers can be omitted. The compiler will take care of the numbering. Okay. After assembling our WAT file with WAT to WASM, we can disassemble it again. Okay. As you can see, the name of it identifiers have disappeared and been replaced with helpful comments. You can also see a type declaration that was generated. Okay. Writing code for a stack-based machine can sometimes feel a bit weird. WAT also offers folded instructions. Okay. If we compile R and load it into the browser, compilation can start even when the module is still downloading. So we need to use initiate streaming. I saw that another place as well. So we use instantiate streaming if it exists, otherwise use instantiate. Oh, okay. So Emscripten already does that. Good to know. It's important to keep in mind that JavaScript only has 64-bit floats. Some types, like 64-bit integers, cannot be passed to JavaScript without loss of precision. Okay, I think that's what these guys were talking about. I remember now. Floating point. No, I mean, they were talking about precision, but not exactly the same situation. No, we could avoid the temporary store in P1. Probably never going to. Oh, interesting. Okay. Is this still maintained? Assembly script. Wow. Assembly script compiles a variant of TypeScript to WebAssembly. Binarian. Okay. Let's just finish this part. I'm just gonna scroll through it. Don't care about that right now. Okay, cool. Notes on working with C and WebAssembly. This guy is, I believe, talking about the same thing, or very similar what the other guy was talking about. Pragmatic compiling of C++ to WebAssembly. Most programmers I know, but most of troubles getting started. This guide brings you beyond a simple hello world. Stateful applications with interaction between C++ and JavaScript. This might be good. We might need some of these, but I'll go with the documentation over here. See what they say. And this, oh no, never mind, C++. I was gonna say this is C, but it's C++. Um, okay. Maybe I'll come back to this. I don't need to read this right now. Already read through this. It's, I don't know. This is something I might want. Just extra exported runtime C wrap. Maybe. This I believe tells what directory. I think that's really all we would need. But yeah, let's keep going. This guy is saying what I'm trying to avoid. I mean, well, he talks about it right here. This is what I'm trying to do. Uh, yeah, hosting on a server is basically what I'm trying to avoid. Is this the original poster? Oh, guy has a lot to say. That's that. Hmm. Okay. Ah, this is the one that I didn't. I like what this guy's saying. I like how he lays it out. EMCC, I think instead of referring to a single file, I'm going to refer to multiple files, but we'll see. Alright, I'll come back to this. What I do need to do is try this, because I did get an output before, so I need to try that. I don't think it's going to be what I'm looking for, but let's just give it a shot. Okay, so here's the issue. Back to the issue. So they have instructions for building, and this is what I've done. And I believe this will work, but the issue is it doesn't use, from what I can tell, it does not use EMCC. So I need to get either that to use EMCC or I have to download the source code and download and install the source for the dependencies, and there's a lot. Well, not a lot, a decent amount. So that would be kind of annoying if I have to do that for each one, but not a huge deal. But it would be nice to get just this working, and replace, I believe these are like scripts or something. Uh, what is this? Where's the code for this? I'm actually going to stop here for now. Um, I know I didn't do anything except read a couple articles, but um, yeah, I'm gonna continue next time and actually try to build it, which I've done before. And that's pretty much where I was at before. I did get through, made that work, running these commands, and it built, but then it wasn't sure what to do from there. So next time I will look into that. I might be back pretty soon. I'm not sure. But, for now, I'm gonna go and come back later. Thanks for watching.